welcome to Succeed e-learning app. Today we are going to learn about surface area volumes. In your class 9, you're familiar with a lot of basic solid structures, for example, cuboid, cone, cylinder and sphere. We have also learnt about finding the surface areas and volume for these solids. Let us take a look at an object. You must have seen this object in your science laboratories. So what is it? It's a test tube. Yes. Now, this tube is also a combination of a cylinder and a hemisphere. Similarly, while traveling, you may have seen some big and beautiful buildings or monuments which are made up of combination of solids which we have already learnt before. So, if for some reason, if you were wanted to identify or calculate the surface area or volumes or capacities of these objects, how would you do it? So, for such cases, we cannot classify these under the basic solids that we have already learnt. In this chapter, you will see how to find the surface area and volume for those objects which are a combination of the basic solid structures that we already have. Let us consider an example to understand this topic. In the figure, you see a container. So, how do you find out the surface area of this container? Remember, whenever we had a problem, we always broke it into smaller sets of problems and we tried to resolve it in our earlier classes. Similarly, here as well, we are going to break open this container and try to see the different shapes of it and find the surface area volume of it. Now, if you break this container into different halves, you are going to see a hemisphere followed by a cylinder and another hemisphere. If at all you have to find out the surface area volume of this particular solid, you will have to identify what is the surface area volume of the containers, that is the hemisphere and the cylinder and another hemisphere. Therefore, we can derive the TSA of this container as TSA of a container is equal to CSA of one hemisphere plus CSA of a cylinder plus CSA of another hemisphere. Now, what is TSA and CSA? TSA refers to the total surface area and CSA refers to the curved surface area. So, this is how we are going to find out the total surface area of this particular container. Meanwhile, let us look into another example. Now, let us consider another situation. Suppose you have to make a toy by putting two different solids. So, here let us consider cone and a hemisphere. Now, if you are given with a cone and if you are asked to join the hemisphere to it and make a toy, how are we going to do it? So, we select a cone which has the same radius as that of a hemisphere and place it on the curved surface so that they will attach. So, this is how we are going to do it. At the end of our trial, we got ourselves a nice round bottomed toy. Now, if we want to find out how much paint we would need in order to paint this particular toy, we will have to identify what is the surface area of this particular toy. So, if you have to identify the total surface area of this toy, you have to understand that we have to divide it into two different halves, that is of a cone and a hemisphere, and find their curved surface area separately and then sum it up in order to get the total surface area of a cone. Therefore, you can actually write this as TSA of this toy is equal to CSA of the hemisphere plus the CSA of the cone. Let us find out volume of combination of solids. In our previous sections, we have learned how to find out the surface area of combination of solids. Now, in this section, we are going to see how we are going to identify the volume of the combination of solids. Imagine that we are going to break this problem into smaller pieces and identify the volume of each of those objects in order to find the volume of the actual figure that is given to us. Let us take a look at a question in order to see how we are going to solve it. Shanta runs an industry in a shed which is in the shape of a cuboid summoned by a half cylinder. Take a look at the picture. If the base of the shed is of dimension 7 meter into 15 meter and the height of the cuboidal portion is 8 meter, find the volume of air that shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meters square and there are 20 workers, each of whom occupy about 0.08 meter square space on an average, then how much air is in the shed? So, for this example, consider pi as 22/7. We know that the volume of the air inside the shed when there are no people or machinery in it is given by the volume of the air inside the cuboid and inside the half cylinder taken together. Now, the length, breadth and height of the cuboid are 15 meter, 7 meter and 8 meter respectively. Also, the diameter of the half cylinder is 7 meter and its height is given by 15 meters. So, the required volume is given by the volume of cuboid plus half of the volume of the cylinder, which is equal to 15 into 7 into 8 into half into 22/7 into 7/2 into 7/2 into 15 meter square. On calculating, you get the answer as 1128.75 meter cube. Next, the total space occupied by the machinery is given by 300 meter square and the total space occupied by the workers is given by 20 into 0.08 meter square, which is equal to 1.6 meter square. Therefore, the volume of the air when there are machinery and workers can be calculated as 1128.75 minus 300 plus 1.6, which is equal to 827.15 meter cube. So, the next topic is conversion of solid from one shape to another. So, you all must have seen candle when it burns. So, this candle will be melting into a different shape altogether. Previously, it will be in cylindrical shape, but once it starts melting, it gets transformed to a different shape. You must also have seen a candle which is of a fancy shape that can be of an animal, of any other designs than the cylindrical shape. So, how are these made? The candle is actually burnt into a liquid wax and then it is poured into another container which has this fancy design. So, whenever you are calculating the surface area volume of the objects which is of non-standard shapes or which is converted from the standard shape into another, you always have to remember that it was initially in the standard format and then it was liquidized or it was poured into a different form. Now, to understand this better, let us consider some examples. A cone of height 24 centimeter and radius of base 6 centimeter is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. Now, we have been known that volume of a cone is given by 1/3 into pi into 6 into 6 into 24 centimeters cube. If r is the radius of the sphere, then its volume is given by 4/3 pi r cube. Now, we know the values of all of these. Now, substitute the values in the formula. So, you get 4/3 into pi into r cube, which is equal to 1/3 into pi into 6 into 6 into 24. Now, r cube is equal to 3 into 3 into 24, which is equal to 3 cube into 2 cube. Therefore, the radius of the sphere is 6 centimeter. Let us move on to the next topic, that is frustum of a cone. In your previous section, we have seen how objects are formed by joining two different solids. Now in this topic we are going to see a different side of it. That is, we are going to consider a right circular cone and remove a portion of it. So we are going to cut this right circular cone in a particular portion, that is in a plane which is parallel to the base. Now let us see some examples on how we use this knowledge in order to solve the questions. So we know that the frustum can be viewed as a difference of two cones. If you observe the figure, those two right circular cones are OAB and OCD. Now, let the height in centimeter of the cone OAB be h1 and the slant height L1, that is OP is equal to h1 and OA is equal to OB is equal to L1. Let h2 be the height of the cone OCD and L2 be the slant height of the cone. We have that L is equal to 28 centimeter and h is equal to 7 centimeter. And the height of the frustum h is equal to 45 centimeter. Also, h is equal to 45 plus h2, that is the height 1 of the right circular cone is equal to 45 centimeters plus the height 2 of the right circular cone. Now, we know that we have to determine the respective heights h1 and h2 of the cone OAB. How are we going to do it? This is being done by the formula h1 by h2, which is equal to 28 by 7, that is 4. Now mark this as equation 2 and mark the previous one, that is h1, which is equal to 45 plus h2 as equation 1. Now from equation 1 and 2 we can write it as volume of the frustum is equal to volume of the cone OAB minus volume of the cone OCD. Now substitute the values and you get 1 by 3 into 22 by 7 into 28 centimeter square minus 60 minus 1.3 into 22 by 7 into 7 square plus 15 centimeter cube. On resolving, you get 48,510 centimeter cube. Now, the respective slant height h1 and h2 of the cones OCD and OAB can be given by L2, which is equal to square root of 7 square plus 15 square, and you arrive at the solution which is 16.55 centimeter, which is in approximately. Now, L1 can be given as square root of 28 square plus 60 square, which is equal to 4 square root of 7 square plus 15 square. On resolving, you get 4 into 16.55, which is equal to 66.20 centimeter. Thus, the curved surface area of the frustum can be given by the formula pi r into L minus pi r2 into L2, which is equal to pi, the value of pi is 22 by 7. So, substitute that here, you get 22 by 7 into 28 into 66.20 minus 22 by 7 into 7 into 16.55, which on calculating will give us 5461.5 centimeter square. Now, the total surface area of the frustum needs to be calculated. This can be given by the curved surface area plus pi r1 square plus pi r2 square. On substitution of the values, you get 5461.5 plus 22 by 7 into 28 square plus 22 by 7 into 7 square. On calculating, you get 5461.5 plus 2464 plus 154 centimeter square. Adding all of this, we get 8079.5 centimeter square. Let h be the height and L be the slant height and R1 and R2 be the radii of ends, and let us consider that R1 is greater than R2. Now, this is for the frustum of the cone. Then we can directly find the volume, the curved surface area and also the total surface area of the frustum by using the formula which is given like here. Volume of the frustum of a cone is given by 1 by 3 into pi into h into r1 square plus r2 square plus r1 r2. The curved surface area of a frustum of the cone can be given by the formula pi into r1 plus r2 into L, where L is equal to square root of h square plus r1 minus r2 the whole square. Also, the total surface area of the frustum of a cone can be given by the formula pi into L into r1 plus r2 plus pi r1 square plus pi r2 square, where L can be written as square root of h square plus r1 minus r2 the whole square. So, this formula can be derived using the idea of similarity of triangles, but we are not going to derive the formula here. Now, let us see how we are going to use this formula in order to get the solution for this question. First one, that is volume of the frustum can be calculated by 1 by 3 pi h into r1 square plus r2 square plus r1 into r2. Now, let us substitute the values in order to see the solution. This can be written as 1 by 3 into the value of pi, which is 22 by 7, into 45 into 28 square plus 7 square plus 28 into 7 centimeter cube. On calculating, you get the solution as 48510, that is 48,510 centimeter cube. Moving on to the second sub question. We have that length L, which is equal to square root of h square plus r1 minus r2 the whole square. On substitution, we get square root of 45 square plus 28 minus 7 the whole square, which is equal to cube root of 15 square plus 17 square, which is equal to 49.65 centimeter. Moving on to the next sub question, which is to calculate the total curved surface area of the frustum. This can be given by the formula pi into r1 plus r2 into L plus pi r1 square plus pi r2 square. On substituting the respective values, we get 5461.5 plus 22 by 7 into 28 square plus 22 by 7 into 7 square. On resolving, we get 8079.5 centimeter square. We have come to the end of the session. I hope you enjoyed learning with us. For more such videos, keep watching Succeed e-Learning app.